Hello.
Talk about first.
Yeah, hello. Hello, Mr. Eric. Hello, Mr. Ryan.
Hello.
Do you still remember the factorial? Factorial. Please.
Yeah.
What does it equal?
One times two
times
equals is 6.
Yeah, okay. How about 5 factorial?
What?
5 factorial
1 times 2 times 3 times 4 times 5.
equals how many?
Equals 120.
How many zeros? How many zeros?
1.
1 0. Okay, so the question today is very simple. N factorial. Count how many zeros at the end. Yeah, think about it. Look, 5 factorial is 120. So 1 0. You should return 1. And then maybe 6 factorial equals 720. It's still 1 0. So do you see any of the problem?
How do you work it out quicker
Yeah, how do you quick work it out quicker?
without just getting to count?
Of course, you can.
All you just do is 0, 0, 0, 0, then 1, 1, 1, 1,
Wait.
then 2, 2, 2, 2.
First of all, the solution will be you calculate this actual value, yeah, and then count how many of them, yeah.
Yeah.
Okay, let me write
This
it
is a
down.
bit slow.
Yeah, it's very slow. Yes, you're right. Let's
We're
see.
When I'm doing it, I'll count in 24 times 5.
Okay, count 0. Let's n factorial. Okay.
Oh,
Look, answer. Let's say factorial. Okay, f factorial equals 1 first. For I in range 2 to the n plus 1, right? Column, yeah? And f1 times equal what? F times equal what?
N.
Every time I. Yes, you're right. Now f is the n factorial, yeah? Now f is n factorial. Now we want to count how many 0, right? Yeah? We want to count how many 0, right?
Is 0
Yes.
equals 1?
Yes? Right? We want to count how many 0, right?
Yeah.
Right, Eric? So now look, we can have these zeros. Let's zeros equals 0 first. Yeah, first. Then look. Y what?
Why are zeros?
We want to count how many zeros.
Zeros.
Now f.
Count.
No.
Does it count zeros?
Now y f modulus 10 is 0, is still 0. Then f divided equals 10. Remove 1 0 and zeros plus equals 1, right? And then return 0. Am I right?
Yeah.
Is it true?
Mm-hmm.
What's the term complexity? What's the term complexity? Look, do you understand this? Look, if this 120, f is 120, yeah? Y 120 divided by 10, remain is what? 0, right? Yeah?
12.
And then f is this, then divided by 10, it will become, f will become 12. I take away 0, and I put one increment 1 0, right? So it's 1, return 1. Do you get it? Yeah? Yeah. What's the term complexity?
1. No, not A1, not A1.
No.
Is it what?
Can't be A1, can't be.
Look, this looks like ON, right?
Yeah.
But actually, look, you times it together. This number is actually, when you count how many zeros, it could be actually goes to ON square, right? Because this is a very huge number. Yeah? Yeah? Yes? And this number could be actually ON squares. Think about that way, yes? If each I had each multiplication adds 1 more 0, right? Yeah? So how many zeros at most?
At most.
Yeah? How many zeros?
At most.
Yeah.
1.
I think 1. Yeah.
1?
No, actually
10,000.
10,000. No, just kidding, eh? 3 why?
3
I'm
what?
just
Why?
guessing.
Okay. Anyway, this
One
method is very slow. Am I right? This
No.
method is very slow. Yeah. Is it very slow?
Yeah.
So can we do better? Can we do better? Can we do better?
Now remember what's here.
Huh? Can we do better?
What's here?
This the complexity for this one is O(n) squared, but it's a bit complicated. We'll leave it to later. Okay. So can we do better? How do you know why we get a 0 at the end? What times what is equal to 0?
0
Can you
times
think about
0.
it?
0 times 0.
Normally things.
No, but at factorial, look, n factorial, there's no 0 in there, right? So anything apart from 0. So how do we get 120? What times 1 times 2 times 3 times
4 times 5.
times 4 times 5? Which numbers make a 0 at the end?
2 times 5.
Yeah, we are down 2 times 5, yeah?
Yeah.
Okay, so now these actually 4 is also 2 times 2, right? Yeah, so factor, talk about factor. So actually we want to count the factor 2 and 5, yeah? So these 2 could go with 2 times table, yeah? Yeah?
Okay.
And this will be 5 times table, right? Yes? Am I right? Yes? So look, any of these comes together, you will result a 0 at the end, right? You see?
10,
This is 2
4,
times table,
10.
5 factor, right? Yeah? So we just want to count how many factors of 2 and how many factors of 5, yeah? And the minimum will be the number of 0, am I right?
Hmm?
So do you think we need to count both or we can just count one of it? Which one is definitely more?
Which one?
Yeah, which one is definitely more? The factors, number of 2 or number of 5, which one has more? Is more?
2?
Yes, of course, look. Yeah, each even number has 2, right?
Yeah.
But this is every 5 has 1, right? This is,
Yeah.
and this has 2, right? 5 times 5, yes? Yes?
Yes.
So we just need to count how many 5s, right?
Yeah.
Yeah, how many 5s? We don't need to calculate actual factorial. We just need to count how many 5s in each number factorial, right? So how we can do this? We can do this. 0 equals, first of all, is 0. Okay, and then now for I in range, we start from 5, right? Because from 1 times 2 times 3 times 4 doesn't produce 0, right? Yes?
Yeah.
So 5, and then this will be n plus 1, and every step 5, right? And now we can say current equals I. Why? Current, what? So now we need to count how many 5s in this number.
Well, current 5.
Sorry?
Current 5.
What do you mean current 5? Huh? What do you mean current 5? We want to count how many 5s, so how do we do this?
How many 5s? Not zeros.
Yeah, we count how many 5s. So if current divided by 5 is 0, can be divided by 5, then we added this 0 plus equals 1, and then current divided by 5, right? And then return 0.
Why is divided by equal 5?
This thing is the same as current equals current divided by 5, integer, yeah? To divide this means I want the integer, only the integer part, yes? Alright? What's the time complexity?
Oh.
What's this time complexity?
N2. Right. N times N.
Yeah, sorry?
N times N.
Quite close, ON. Yeah, this is N. This looks like possibly, I mean, because every time divided by 5, so I'll log N. But actually this is quite small, because look, it could be any number divided by 5 will be 5 25, 125, 600, what? 25, yes? And this will be very, very, very small, okay? So actually you can say n log 5 base n, yeah? Yeah?
Yeah.
Yes?
Yeah.
Yeah, okay. So this is the same as I can do it the other way. So current, I can say power of 5 equals what? 5. Right? And then I can say this is the same. Current moduli power 5, and then I say power 5 times equals 5, right? This is the same thing, yeah? Is it the same thing? Is it the same thing?
Yeah. Is it the same thing?
Is it the same thing? Yes, is it the same thing, yeah?
Yeah.
So look, first of all it's 5, I divided 5, and then 5 times 5 equals 25. I check how many 5s. How many 5s? Yeah? Because 25 has 2 5s, and the next one is 125 has 3 5s, yes? Yeah, got it? Got it? Yes? So can we do even better?
Yeah.
Can we do even better?
Of doing counting zero.
So we just want to count how many 5s, right? Yes? We just want how many 5s.
Yeah.
This has 1 5. So let's say, okay, look, 30 factorial. It equals 1 times 2 times 3 times 4 times 5. Yeah? And then 10, 20, 15, 20, 25, 30.
That's a lot. to
How many
calculate.
5s? How many 5s? How many 5s?
Probably 6.
Catching.
6 5? Not exactly. Look, this is 6 5. Yes, 6 5. You need to 30 divided by 5. That's 6 5. But this, look, this is another one. 5 times 5. Okay? So that means I need to plus 30 divided by 25. This is 1, right? Only integer part. So it will be 6 plus 1 equals 7. Yeah?
Yeah.
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 So again, if I go to 125, come to 250, and here will be,
250. That's a lot.
look, do you see it? Yeah? Yeah? So 5, 25. So basically, the number of 5s is what? N divided by 5 plus N divided by 25 plus N divided by 125 plus N divided by 625 plus. Yeah? Do you get it? Am I right? Yeah?
Yeah.
So how can we write this code? How can we write this code? Let's the answer. Okay, answer equals 0.
Yeah.
And then y.
At the end, return answer.
Yeah, return answer. Okay, so think about it. How do we calculate this? Divided by n divided by.
And divided by 5.
Sorry.
And divided by 5.
Yeah, n divided by 5. Yes.
Yeah.
Now, when n is bigger than 0, then what?
And divided by 5.
N divided by 5. That's right. N answer plus equals what? Plus equals what?
N. No factorial.
Yeah, well done. How do you know? Plus equals, and then that's the answer. Yeah? It
Yeah.
will be simple. Look, if it's 0, I divide it by 5, and then I can count it, add it, right?
Yeah.
Why this helps? Why this is okay? Why this is okay?
I don't know.
You don't know. Look, if it's 25, look, 25, you should give me how many 5s? 25. 1 times 2 times 25 will be 3 5s, yes? 25 divided by 5 is 5. Answer plus 2. Yeah? Look, 25 divided by 5 is 5. Okay, is it true?
25 divided
No,
by 5.
that's a problem here. if it's n is 25, n is 25 factorial. So how many 5s are in there?
2.
No, I mean the whole answer. 1 times 2 times 3 times 4 times 5.
1.
They are 5, 10, 15, 20, 25. They are 1, 2, 3, 4, 5. So at 25 divided by 5 is 5. I answer add 5. Okay, so that's, and then 5 divided by 5 equals 1. I answer add 1 more plus 1. So it's 6. You see how this goes? Yeah? Look, the first thing I divided by 5, and then I can see how many 5 timetable, right? And then I again divided by 5, then that's 25 timetable. Yes? Yes? And I again divided by 5, that's what timetable? 125 times table. So this will work on it. And do we have another way of doing it? It's the same. So we can say this we can say current multiple. Okay, so answer equals 0, and then we have a let's say power of 5. Power of 5 equals what? 5. Why? Why what? Why what? Why n bigger than equal the power of 5? Answer plus equal what? N plus equal what? N divided by current multiple, yeah? N divided by power 5. And then power 5 times equals 5. And then return what? Return what?
Answer.
Yes, answer. So it's the same thing as look. It's previously it start from this is 5, and then I answer n divided by 5, and then n divided by 25, and n divided by 125. Yeah, this goes in. Yeah, yeah, yeah. Again and again. Yeah. So this complexity is better. So what's the complexity? What's the complexity? What's the when the complexity you can ignore this, you just ignore this. Yeah, look, yeah. So the complexity is O what? O what? Log 5 base n, right? Because this, yeah, yeah. Because look, times 5 until it's bigger than that, right? Is it?
Log 5 base 10.
No, base 5 n.
N.
Yeah, is it true? Let me think about it. Yes. Yes. Yes, because
that was a long time away.
this is basically the same as look, because every time 5, and then the next one is 25, and the next one is 125, right? So it's every time is 5 to the power of x should be smaller, is equal to n, right? So this n, 5 to the power of x equals n. Then what can we do? So x is log 5n, right? Yeah? So the complexity is this one. It's the same as previous one.
Log 5 base n.
Yeah. Do you still remember previous method? Do you still remember?
The first one.
No, the one previously. Like answer equals 0, y. We divided by 5. How do you get it?
N.
Yeah? And bigger than 0? Yeah? Yeah? And then answer plus equal what?
N.
Actually, it should be n should be divided by 5 first. Yeah?
Yeah.
And yeah. Return
Answer.
answer. It's the same thing, yeah? So this is also every time divided. Every time divided by 5, and then... Yeah, and then, because look, when n is 5, you divide it by 5, it will be 1, answer plus equals 1, okay? So return answer. So that complexity is still the same, all log n, okay? Okay, so now, I'm going to erase this. The last thing, can you write it?
Fine. I didn't even look.
I mean, equals.
Yeah, means, and then,
Okay,
yeah, let's tick. Tick. Okay. Okay. Next one. I tick it. Tick.
Say.
So I want to add this to the answer. How do you write it?
Answer.
I didn't have time to think. So I don't know, babe.
Equals.
Equals. Yeah.
N.
Wow, well done. You want the challenge?
I didn't have any look.
You can look it over, and then how about this one? Okay. You want to look? Okay. 1, 2, 3. Okay. Okay. So now I'm going to erase this. Finish it. Think about it. Can you think about it? No?
Don't want to.
Why? You want Eric to help you? Okay, that's fine. Okay, Eric, you want to write help Didi? That's fine. Yeah, Ryan, you look at it. Look, Eric helping you. Come on, you're a good boy. Yeah, you're on YouTube. But be careful. Remember, yeah. Don't.
You're more than Eric.
What's more than that?
It's more than Eric to write.
It's okay. Okay. How about you? Okay. Come here. Write this one. Now you should remember. Yeah. What does it mean?
Babe.
Now plus equals n, not equals n. Okay. What's that? Okay. Okay, that's good. Good today. What's the time complexity? What did I just say?
Log 5n.
Okay, that's it for today.